Think of your body as a sprawling, futuristic megacity powered by a pulsing central reactor core. At the microscopic level, life is simple. A tiny, single-celled organism like an amoeba doesn't need a complex transit system to survive. It can just float in the water and let nutrients soak right through its outer edge. This effortless soaking happens naturally, letting tiny life forms drift through their environment and absorb exactly what they need to grow and maintain themselves. But you are made of trillions of cells. If a human being relied on that slow, drifting process to move supplies, it would take years for oxygen to travel from your lungs to your brain. To solve this, nature developed a high-speed, pressurized delivery network, the circulatory system. Without this continuous, high-speed transit grid, the massive architecture of your body would starve and collapse. The engine of this megacity is the heart, a fist-sized double pump keeping everything in motion. Inside, the work is divided. The upper chambers receive the incoming fluid, while the larger chambers below forcefully blast it back out into the grid. But when the pump fires, you need a way to keep the fluid from splashing backward and losing momentum. As seen in this diagram, the heart uses valves that function as strict, one-way mechanical doors. As these doors snap shut against the pressure, they create the famous lub-dub sound of a heartbeat. This engine repeats that cycle roughly 72 times a minute, every single day without ever stopping for maintenance. The heart functions as a precisely timed mechanical engine, maintaining a relentless rhythm to ensure that life-saving momentum is never lost. Once the fluid leaves the heart, it enters the body's main transit tunnels. It first enters the arteries, thick, elastic, high-pressure pipes that carry oxygen-rich fluid away from the central reactor. To get back, the fluid uses veins. These are wider, lower-pressure return pipes equipped with their own gates to keep everything moving toward the core. But how do these massive highways deliver microscopic goods to a single cell in a remote part of the body? The highways branch off into capillaries. These are microscopic connecting bridges where the actual drop-off of nutrients in oxygen happens. This three-tier grid, arteries, veins, and capillaries, ensures that every single cell remains directly connected to the main power source. For a long time, we didn't understand how this worked. People used to believe the body constantly used up its blood and had to manufacture brand new supplies every day. In the 1600s, Dr. William Harvey studied these vessels and realized the body actually uses the same blood over and over in a continuous loop. Harvey calculated how much the heart pumps and proved it was mathematically impossible for the body to create new blood that fast. However, Harvey had a problem. He couldn't actually see how the outgoing arteries connected to the incoming veins. It took an Italian scientist named Marcello Malpighi to finally find the physical connection between the two sides of the system. By looking at bat wings under a microscope, Malpighi spotted the invisible capillaries, finally completing the map of how our blood circulates. It took the invention of the microscope to prove that our body relies on a unified, closed-loop transport architecture. A moment of wonder. Today, we can see this entire glowing system operating in unison. Every time your heart completes one full round of squeezing and relaxing, it has finished a single, synchronized loop of work. This heavy mechanical pumping creates a surge of physical force that hammers against the walls of your transport pipes. Doctors use tools like this to measure the intensity of that internal pressure, checking both the peak of the blast and the quiet moment while the chambers refill. You can find this rhythm yourself. Place 2 fingers on your wrist, right below your thumb. The rhythmic push you feel on your fingers is the physical shockwave of that pressure traveling down the artery. That simple tap on the wrist is the real-time echo of a biomechanical reactor keeping the megacity of you alive.